All right, here's our lesson video going over pages 9, 10, and 11. We are going to make sure that we are using the state plan do conclude procedure to be able to write our confidence interval. So I'm going to walk you through a couple examples that work with that. And also we're going to talk about how to get sample sizes. So first, to do this lesson, you're going to need to go to random.org/geographic coordinates. The goal of this lesson is to estimate the proportion of Earth that's covered in water. If you have this link handy, you can click right there and that'll pull it up. So let me see that here. And because I don't have a globe in my hand, what I'm going to use is just find some random coordinates on here, and we're going to pick a random coordinate and we're going to kind of combine our data together. So we're hopefully we maybe get 100 samples in class, but since you guys are watching this without me going over it with you, we can use the same data here. So if I were to do this 100 times, you know, we're trying to figure out what percent of these locations are covered in water. And you can kind of see, well, it looks like more often than not, well, if I keep doing this enough, I'm going to find lots of points here that are definitely covered in water. And if you look at, if you remember anything about some geography classes you may have taken before, you're going to find that I think we've been told roughly 2/3 of the Earth is covered in water. Now, I don't know that off the top of my head, what exactly that percentage is, but we're going to go ahead and just kind of keep that there. Okay. So let's go ahead and let's assume we did 100 samples. And let's say between all of us in class, we did 100 samples and we found, based on the 100 samples we did, that, I don't know, let's say 65 of them were covered in water. So not quite 2/3, 65 of them were covered in water. And of course, it says calculate the proportion of locations from the sample that are water. So you know that 65 out of 100 would be 0.65. Okay, so our goal here is to construct a confidence interval to estimate the true proportion. Estimate the true proportion. I'm going to write true of locations on Earth that are covered in water. So with that state part, the first thing we want to say is, what is our parameter? State the parameter you want to estimate in the confidence level. So it doesn't, it tells us what the confidence level is. So we are going to put that on there. If it did not, if it just says estimate it, then you would use 95%. You know, you don't have to, think too hard about it. 95 is the default. So if you're not given one, use it. But it also really kind of tells you the parameter right there. Just say true. So the parameter is the true proportion of Earth covered in water. So you just write that down, right? So again, this is just a made up number. I didn't actually go through and click 100 times, but if we were to figure this out, if we're going to estimate the true proportion, we're going to call this a one sample Z interval for P, not P hat, because we're trying to estimate P. So it's for P, not P hat. The plan part is what we're going to check the conditions are. So we name the procedure. It's a one sample Z interval for P. We want to verify, was this done randomly? Well, I went to random.org. So yeah, that's going to be random there. So the locations were picked randomly. Has it met the independent condition? Are we less than 10% of all locations? Now, Earth has a lot of locations on it, right? So if I take 100 in our sample and I times that by 10, there should be hopefully more than 1,000 locations on Earth. So it's safe to say there are less than 1,000 locations on Earth. We have met that 10% condition, okay? Have we met the approximately normal condition? Remember, that's your large counts. So we want to know, does NP hat, we don't know P, so we say does NP hat and does N1 minus P hat both give you numbers that are going to be greater than or equal to 10? So we have to state that. We have to write that down. And so, of course, our successes and failures and NP hat is going to be 100 times 0.65 and 100 times 0.35. And both of those are going to be, 65 and 35. So we've definitely met that condition. So we're good to move on. Okay, I've got 65 and 35 as my successes and failures on there. So we've done the plan part. So the state is simply going to be, hey, what are we trying to do? What are we trying to estimate? True proportion of each of Earth covered in water. State your confidence level. The plan, we're going to plan out what we're doing. We're going to construct an interval. One sample is the interval for P. We're going to list our conditions. Okay. Now the do part, that's where we're looking at your formula sheet. And you don't get much but a generic formula. So, if we're looking at our formula sheet, that's about all you get, right? Confidence interval is your statistic plus or minus your critical value times the standard error of the statistics. Not very helpful, but we're going to go ahead and write that down anyway. So, but I'm going to write it as the things I would plug in. Okay. So first I'm going to write statistic plus or minus critical value. And I'm just going to write standard error. And then from there, I'm going to plug in the specific things I need. So our specific formula is going to be p hat. Our critical value is a z star, right? So that's going to be what we're going to calculate either using table B or your inverse norm. And our standard error is on the back side of this page. So it's going to be this right here. So you can look on your formula sheet to find that part of it. P hat 1 minus p hat over n all under the square root. Do that here. So once you have all that written down here, we can plug in our numbers. We know that our p hat is going to be 0.65. We calculated that up here. So our p hat is 0.65. Our z star, we should know now at this point, 95% is going to be 1.96. I think we should just need to memorize that one because that comes up so often. But again, you can use the bottom of table B if you need to. So the very second to last page, 95%, 1.96, or you can use your inverse norm and average that with 1. Again, not everybody has a center option. So when you're using inverse norm, second vars, third option down, average your 95% with 1. So do parentheses 1 plus 0.95, close the parentheses, divide by 2, leave that as 0 and 1. And that'll give you the z star that we're looking for, 1.96. We're going to plug in our standard error, so 0.65. The 1 minus p sometimes is called q, so the q would be 0.35. And then your n is 100. And that's pretty much it. We do want to actually calculate this number if possible and just add it back to the 65 and subtract it from the 65. So I'm going to go ahead and type 1.96 square root 1.96 square root 0.65 times 0.35 divided by 100. Notice I didn't need to use parentheses here because I didn't do 1 minus, so I just threw it all in. And I'm getting a margin of error of about 9.34%. I'll just say 0.093. No need to go out too far. So 0.65 plus or minus 0.093. And there you have it. That's your margin of error. And so MOE or ME, I'll just call it ME. That's your margin of error. And now we can find our interval. So our interval is going to be the difference and the sum, okay? Your 0.65 minus 0.093 is your low end. No need to actually show the subtraction on there. That's kind of implied. You know how to do that. So 0.557, comma, and then 0.65 plus 0.093, 0.743. And finally, our conclusion. Okay, so once you calculate your interval, you're going to check it in your stat menu. You're going to go to stat, tests, one prop z int, option A. You're going to input 65 for your number of people that actually said they got water for their locations. You're going to put 100 for the total number in your sample. We'll leave that at 0.95 for your confidence level, and we're going to calculate. And that should be consistent with what we calculated without your menu here. And so you have your sample proportion, your sample size, and your interval without the margin of error written in there. And so our final conclusion is we are 95% confident that the interval from, and then we have to write our interval. So the interval from this number to this number, so 0.557 to 0.743 captures or contains, and then we have to write our parameter in context. So we are 95% confident that the interval from 0.557 to 0.743 captures the true proportion of Earth covered in water. And that kind of takes care of all of those things. So that's your state plan do conclude as a problem there together. That's how you'll do those, although you won't have the little template telling you state plan do conclude. But you want to think when you're doing a problem to do things in that order as you're solving your problems out there. All right, let's go on to the next page. On the next page, I filled a few things out for you guys. Just kind of summarizing the state plan do and conclude. Please feel free to pause these as you want to write these down. Again, you have that template, so it really already is there, but this just reinforces it in maybe a smaller location. So we want to state, write our confidence level. We want to make sure we do context here. Make sure we check our conditions and name what we're doing. One sample z interval for p. We want to complete our work. So we want to plug in the formula, write our formula, plug in the numbers, and actually compute the A to B interval. And remember to check it in your calculator. Okay, stats test one prop z interval, just to make sure you got it right. Because if push comes to shove, if you can't figure it out by hand, well, you can at least get it on the calculator and do all the other stuff and maybe just not have your work. Okay, and then our interpret is we are 95% confident that the blah 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 blah. So interpret, state, plan, do, conclude. Now I haven't gone over an example that shows how to get sample size. However, let me just kind of give you a generic what to write down here. Our goal here is to be able to solve for n. So if I'm trying to figure out if I'm given a margin of error, can we figure out an appropriate sample size based on our confidence level? So what you're going to end up doing is you're going to solve for n. You're going to divide both sides by this z star. It's going to make more sense as we go over an example. Then we're going to square both sides. You're going to multiply both sides by n again. And you're going to divide both sides by the margin of error over z star, that number squared. Always round up. And if we don't know what our sample proportion is, we're going to use a conservative estimate of 0.5. And you're going to be asking, what on earth are you doing? Because you haven't even gone over an example. Well, let's go over this, check your understanding. So I'll go over both of these questions and check understanding number 1 and number 2, so you can kind of get an idea. Please do them with me, okay? I can't stress this enough. You have to actually have to do the solving to be able to understand what's going on. Your calculator is your friend on here. So let's pull out our calculator, okay? We're going to read through the problem. The problem here is that a company has received complaints about its customer service. Managers intend to hire a consultant to carry out a survey of customers. Before contacting the consultant, the company president wants some idea of the sample size that she will be required to pay for. She has no idea of the sample size, but she has to figure out how many people to ask. You got to know who you're asking and how many people you're going to ask. So we kind of have to figure this out. So what's going to happen is the value of interest is the proportion of customers who are satisfied with the company's customer service. She has to figure out her confidence level. So she's going to go with 95%. She wants the estimate to be within 3 percentage points. Well, what do you think that is? That's your margin of error. So your margin of error has to be within 3 percentage points. That means it can't be greater than 0.03. So anything at 3% or less is good, okay? Again, what is your Z star at 95%? 1.96. Now, what are we going to do with this? Well, it says using a conservative estimate for p hat. How large of a sample is needed? Well, again, we don't have any proportion here, right? No sample, nothing was conducted. So when you don't know what you're working with, we're going to use 0.5, okay? Now, what is going on with this? Why am I using 0.5? I want you to think about this for a moment. Get your calculator out, and I want you to write the following down, and then we're gonna play around with it first before we actually do any formal solving. We want our margin of error. Remember that our margin of error is z star times the square root p hat 1 minus p hat over n. Y'all should know that, okay? That is your ME, your margin of error. So we want that to be less than or equal to 0.03. So what we do know is we're going to use 0.5 for p hat, and we're going to use 1.96 for z star. We do not know n, so we have to solve for that. So I'm going to write the equation that you're going to use to solve, the inequality rather. You're going to write 1.96 square root, in this case 0.5 times 0.5 over n, less than or equal to 0.03. That is what we're going to try to figure out n. Now, you have a couple approaches to this. If you don't want to do algebra, you can play around with it. It says, how large of a sample is needed? We're trying to figure out the n value that's going to get you just within 0.03. Well, of course we can play around with it. We can say, well, maybe I need to ask, I don't know, 500 people. So you put 0.5 there, 0.5, and you put 500. You'll put this in there, all right? See what happens. Now, what's happening to my margin of error? If I throw 500 in there, I'm going to get a margin of error of about 4.38%. That's a little bit too big. I want it to be smaller than that. So we have to go higher, right? Remember, the higher the sample size, the smaller the interval is going to be. So your margin of error is going to be a little bit smaller. So I'm going to scroll up. I'm going to put that maybe at, I don't know, go a couple hundred more. We'll say 700. And we're getting closer, but we're still a little bit too big. And let's try 1,000. And it's really close to 3%, but still too big. So I got to go, and now we're just nitpicking, right? Is it 1,050? You know, and I can keep playing around with it, and eventually, now I know the answer is, I think, was it 60? Was it 63? No. How about 67? Almost, right? So it looks like I have to go one up, and voila, 68 is the magic number. 1,068 is going to get me within a margin of error of, 3%. Now we're talking about people, so we have to use whole numbers for that n value. Now, you don't want to keep guessing and checking, okay? So we're going to solve for this using this approach. First thing we're going to do is we're going to divide by 1.96. Let's do that in your calculator. So we're going to take 0.03 divided by 1.96, whatever your confidence, your z star is. And then once you have that, you're going to have this square root 0.5, 0.5 over n equals 0.03 over 1.96, right? You're going to take this number right here. So you can scroll up and you can hit the square button. Now, it's a tiny, tiny number. So I would recommend just using your calculator's history and not having to retype it. We want to undo that square root. So that's why we square it, okay? And so what happens is you have this 0.5 times, squeeze this over here, 0.5 times 0.5 over n equals this stuff, 0.03 over 1.96 squared. Well, I want to take this and divide by this to be able to get n. So if I kind of solve it out, if I bring the n up here, I'm going to have 0.5 times 0.5 over this stuff. Equals my n, right? I change it to an equation versus inequality, but whatever, right? So think about it, what you're going to do. You're going to, in your calculator, you're going to take 0.5 times 0.5 divided by, and you're going to scroll up and you're going to reuse your previous number, okay? And notice that it gives you 1067.111 repeating, right? Well, we have to bump that up. We're going to round that up. So anytime that you're given a number, always round up to get your value. So again, once more, if I do 1.96 square root 0.5 times 0.5 divided by 1067, not quite enough, right? We do have to bump that up to 1068. And so that's the method to solve it. Let me walk you through that one more time. Take your margin of error, 0.03, divide by your z star, press enter. Just hit the x square button. That'll square that previous number. That'll undo the square root. And then take your two proportions, 0.5 and 0.5. Divide by that, and then round up. So n should be at least 1068. Okay, 1068 is the smallest sample size to be able to come up with that. Now, what happens if, for letter B, if the company's prior year survey, in the company's prior year survey, 80% of customers surveyed said they were satisfied. Using this value as the guess for P hat, find the sample size needed for a margin of error of at most 3 percentage points with 95% confidence. And it says, how does this compare with the required sample size from question 1? Well, let's go back. We're actually going to use this for P hat, right? So we're going to use a previous survey to help us with that, because that might give you actually more information. And so if I go back, all things the same, 95%, and I use 1.96, but I'm going to use that 0.8. And so your Q would be 0.2, right? 1 minus 0.8 is 0.2. We don't know n. We still want that to be within 3 percentage points. So that's going to be your margin of error. See if you can solve that out. All right, pause it, and we'll check it in a minute. Now, how much work do you have to show for this? Not a lot. You can actually set this up and just give me your answer. If you know the calculator approach, it's this divided by this. So 0.03 divided by 1.96. Just type that out in your calculator. And then undo the square root. So hit the x squared, press enter. And then take your 0.8 times 0.2 and divide by that previous number. And your sample size should be 682.95. We're going to round that up to 683. So if I were to go in there and actually type in 683, we can verify 1.96 square root 0.8 times 0.2 divided by 683 gives you just within 3 percentage points. But if I were to keep that at 682, we're just a little bit over. So we want to bump that up to 683. So again, let me refresh you on the calculator approach. 0.03 divided by 1.96, hit enter. Hit the square button, press enter. And take your proportions. In this case, we're going to use the known proportion. So 0.8 times 0.2 divided by this number here. And then bump up, 683. Here's the work. 0.03 divided by 1.96 squared. And then you're going to divide that from your 0.8 and your 0.2. Don't try to work out all the steps. Just know that n should be at least that number. So n should be at least 683. Round to the whole number. And finally, on part C, it says, what if the company president demands 99% confidence instead of 95% confidence? Would this require a smaller or larger sample size, assuming everything else remains the same in part B? Well, see if you can figure it out. All right, let's play with the numbers, right? We want 99% confidence. What does increasing that confidence level do? Well, think about your table, right? Go to table B. If you got all these levels here, look at your Z star. 95% is 1.96, but I go up to 99%, that's going to actually increase the width, right? 2.576 is your Z star. So everything else being the same, that's what we're working with. Now, if that's my new Z star, if I replace that here, and if I go and type in 0.8 and 0.2, and I try to still be within 3%, let's see what happens, okay? I'm not going to show all the work, but let's go ahead and kind of do the calculator approach. We're going to do 0.03 divided by 2.576, press enter and store that number. We're going to undo the square root. So we're going to hit square. And then we're going to take our proportions. So 0.8 times 0.2 divided by that number. And notice that our sample size went to 1,079.69. So n would have to be at least 1,080 to be 99% confident. Well, what happened? I increased my confidence level, right? My confidence level went up. So if my confidence level goes up, well, that means my interval is going to get wider, right? So your margin of error is also going to go up. So if I want to counteract that, if I want my margin of error to be the same, I'm going to have to decrease or increase my sample size so my margin of error can go back down and get within that 3%. So now, if you think about it, the bigger the sample, the more precise of an estimate you're going to have. So it's going to decrease that margin of error. So it'll counteract that. So the question here is, would this require a smaller or larger sample size? Well, we're going to say a larger, because as you increase your sample size, the margin of error gets smaller, and we want that to go back down since we've increased our confidence level. Okay. You try this one on your own. Pause the video, try it on your own. You can uncheck it and pause it. Just make sure you're verifying, able to get that. And here it is, voila. So hopefully you got a chance to get all the necessary information. Our Z star from our table B or from your inverse norm should be 1.645. We're not given a sample proportion, so I just use 0.5, and your margin of error should be within 4%. So if you plug in your Z star there, standard deviation, 0.5 over n, less than or equal to 0.04. And doing the math here, I'll show you what I did in my calculator. I divided this by this first, and then I squared it to get rid of the square root. But then I took my 2.5s, multiplied them together, and divided by this number here. And I just kind of scrolled up and pressed enter. And I got 422.8, which I want to round up to 423. So there should be 423 people in the sample to be within that margin of error. All right, let's do this last one here. Again, pause this one, see if you can do a state plan do conclude. And after you unpause it, there should be a magically answered question here, and see if it fits with what you have. If not, make a couple adjustments. All right, let's read through the problem. Pew Research Center report on gamers and gaming estimated that 49% of U.S. adults play video games on the computer. So that's going to be your p-hat, because this estimate was based on a random sample of 2001 U.S. adults. So that is your p-hat. Construct and interpret a 95% confidence interval for the proportion of all U.S. adults who play video games. This is our state plan do conclude. Let's look at your state. Hopefully you have something that kind of matches this. We want to state our parameter, what we're trying to estimate, and our confidence level. So I said estimate the true proportion of all U.S. adults who play video games at a 95% confidence level. I'm basically restating that. My plan, I want to name the interval. So it's a one sample Z interval for P. And when you check your three conditions, you should write the following. We say random sample of 2001 U.S. adults was taken. For the independent, we say 2001 is less than 10% of all U.S. adults. Your normal is your large counts, so we want to make sure both NP hat and 1 minus P hat are both at least 10. And they are. So we've done our state plan. Your do is the work. So your do should look like this. You just kind of write your formula down, plug in your numbers. Remember, Z star is 1.96 for 95%. Almost always, well, not always, but a lot of times you're going to use that. So you're gonna find that's going to be very useful. And then one thing that you're going to want to check is you're going to go to stat test A, one prop Z int, and we're going to input. Now we don't know of the 2001. So what I want to do is my large count, this right here, 980.49. So that's going to be 980 on the number up there for the top. And then your N is going to be 2001. And we're going to leave that there. And there's your interval 0.468 and 0.512. So that kind of takes care of that for you. And there's your 49% right there. And finally, our conclusion. We are 95% confident that the interval from these two numbers captures the true proportion of all US adults who play video games. That, my friends, is how we do the state plan do conclude for the one sample Z interval for P. Hopefully with that and knowing how to get a sample size, you're good to go for your Unit 6 Day 3 assignment. Please ask me, reach out for me if you have any questions on your work or just in general if there's anything you need. Y'all have a great day. Thanks for watching.